Good morning, students. So today we are dealing with lecture number how much? 11. So heat and thermodynamics, lecture number 11. So in today's class again we will be going with some numerical part only. So just we will be recalling the processes. So in case of isothermal process, temperature will be constant, correct? No, isothermal T value is constant. Clear? Next, adiabatic process. In adiabatic process, what will happen? Q value will be equal to 0 or delta Q value will be equal to 0, which implies delta Q value will be equal to 0. Again, which implies there is no heat exchange. There is no heat exchange. Clear? Next, in case of isobaric process, pressure value will be constant, and isochoric process, volume will be constant. Clear? So shall we go for the numerical part? Graphical based questions based on first law of thermodynamics. Okay. How first law of thermodynamics should be applied for graphical problems. Okay. In graphs, how they will be asking the questions. So here we are having one question. So in this question what they had given means graphical based question. So here pressure given in terms of atm and here volume given in terms of liter, and here one line they had given, and again they had given that this value is 1 second, this value they had given 1, this value given as 3, this value given as 2, this value given as 4. So these many things they had given, and again they had given delta U in the process A to B. So they had named this point as A, this point as B. Delta U in process AB is given to you. This value they had given 200 joules. Okay. And next they had given that 1 atm liter is equal to 101 joules. Okay, 1 atm liter is equal to 101 joules. And what they are asking in the question means they had asked work done in the process AB is equal to question mark. Okay, and they had given, sorry, they have been asking heat given in the process A to B is question mark. So these two they are asking. First we are going to approach for work done in the process AB. Work done in the process AB means in PV graph how to calculate work done. In PV graph, in PV curve basically, how to calculate work done, area under the curve. Now A to B is this process, area under AB means this complete shaded region. Can you able to see this green color lines over here what I am drawing? Clear? That area we should have to calculate now. So what is the formula to calculate that area of trapezium. So work done in the process AB is nothing but, area of trapezium is nothing but what? Half into sum of parallel sides into width. So half into sum of parallel sides. These two are parallel lines. 1 is 2, 1 is 4. 2 plus 4. Half sum of parallel sides into width of them. 1 to 3 means width is 2. So 2 will get cancelled. 2 plus 4 is nothing but 6. What is the unit? ATM liter. But 1 ATM liter is equal to 101 joules, means 6 ATM liter will be equal to 6 into 101 joules. So it will turn out to be how much? 606 joules. Clear? 606 joules. Clear? So what is the sign convention over here now? Either I should have to write plus 606 joules or minus 606 joules. How to write sign of work done? If volume is increasing means positive. Now from A to B, volume increases from 1 liter to 3 liter means positive value. Volume is increasing, work done value will be positive, remember. Now this one we should have to calculate. QAB, that means heat given to the system in the process AB. Yes, how to calculate QAB? Can anyone tell me? QAB, how to calculate QAB from first law of thermodynamics? First law of thermodynamics is nothing but what? QAB is equal to, or amount of heat given to the process, given to the system is equal to increase in its internal energy plus external work done. Internal energy value they had given in the question, 200 joules. Okay, work done value you had calculated here. Clear? So simply add these two values you are going to get. So delta U value, if I substitute from the question, means delta U value is 200 joules plus work done value 606. So 606 plus 200 means 806 joules. Clear? So this is nothing but what? QAB. Clear? Note down this one. Yes. Shall we go to next problem? Shall I erase the board? Okay. Yes. Next question. In JEE Mains 2014, based on graphical method, listen how they had asked the question. In question, they had given 1 mole of diatomic gas has been used. Okay. So question, 1 mole of diatomic gas. Clear? And after this what they had given means, one graph they had given. So graph is in this manner. So here they had given P, here they had given V. Clear? And next, here one straight line is there. and here also one straight line is there. Clear? Are you understanding what all the things they had given in the question? So first they are telling that 1 mole of diatomic gas, and here we are having one curve. Okay, I hope you are getting this point. Clear? Next, here they had told that this point is A, this point is A, and temperature here is 400 Kelvin. Clear? And this point is B, and informing that B is 800 Kelvin. Clear? And this point C, and temperature given 600 Kelvin. And arrow mark they had shown in clockwise direction. How clock will rotate, in that manner arrow marks they had given. And along with this, what all the things they had given means 4 options for internal energy they had given. So first option is option A, delta U in the process ABCA is 250 R. Delta U in the process ABCA is 250 R. Clear? Next option they had given, delta U for CA is, delta U for CA is equal to, they had given 750 R. 750 R. Clear? Next, delta U in the process AB is given. Delta U in the process AB, this value they had given as minus 350 R. Minus 350 R. And next, one more option they had given, delta U in the process BC. Delta U in the process BC is equal to, this value given minus 500 R. Minus 500 R. So among these 4 options, any one option stands correct for this question. Clear? So how to check now means, go from the options only. So what option they had given, verify whether it is correct or not for the given problem. Listen, first question, delta U for ABCA is equal to 250 R. Always remember, U is nothing but internal energy. I had told you it is a state function. Change of state function in cyclic process will be 0. Okay, that's why this value will turn out to be 0, not 250. That means this option is wrong. Clear? Now, delta U in the process CA. So how to calculate delta U in the process CA now? What is the formula to calculate delta U? So where shall I proceed? Here shall I write? Down part. Okay. For option B, delta U we have to calculate for C to A, we should have to calculate. Here C, here A. Value for delta U is nothing but what? NCV delta T. NCV delta T. Substitute the values. N value is 1. CV is FR by 2. FR by 2. Delta T. 600 to 400. Clear? Value will be how much? 400 minus 600. Final temperature minus initial temperature means value will be minus 200. Clear? So F value is how much? Diatomic gas means F value will be how much? Phi. So phi R by 2 into 2, 2 here 200 means it will become minus 100. That means value will turn out to be how much? Minus 500 R. Clear? Value will turn out to be how much? Minus 500 R. But they had given 750 R, which is a wrong option. Clear? Next. Will you cross check for third option C? Again, delta U in the process AB they are asking. This is delta U in the process CA. Okay. Now A to B they are asking. Shall I erase this part over here? Okay. So C option we are going to check now. Option number C. Delta U is equal to NCV delta T. N is 1, CV is FR by 2, delta T value in the process. A to B we have to calculate now. A to B. 400, 800. Final minus initial. 800 minus 400 means value will be 400 here. So F value for diatomic phi R divided by 2 into, otherwise you just cancel it over here. Two ones are 2 twos are 0 0. So it will become how much? 200. So final value 200 into 5. It will be 1000 R. This is nothing but what? Delta U for the process AB. Clear? So again this value given 350 means this answer will be wrong. Clear? Remaining one is option number D. That value has to be right. Correct now? 3 options is not satisfying means that option should be correct now. Okay. Now last option we should have to cross check now. Simply we cannot judge that that is correct. Let us check that one also. All the 3 we had calculated. Only last one we should have to calculate now. So last option, option number D. Correct? For option number D, delta U we should have to calculate. Delta U is nothing but what? NCV delta T. Clear? N value is half. Sorry, N value given 1. N value is 1. CV is FR by 2. Delta T value how much? In the process BC. This is for delta U in the process B2C. 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 Final minus initial. 600 minus 800 minus 200. So 2 ones are 200. It will cancel. Negative sign is there. F value is 5. 5 into minus 100 minus 500 R. Minus 500 R. Clear? So option D stands correct option for this question. Clear? In this method you should have to solve these questions. Okay? If graphical questions they are asking means read it thoroughly, go through the problem clearly, then approach that problem. Clear? Shall I erase the board? So I'll be writing the formulas now. Listen. Formulae which all we had used. First one, delta U value. What is that? NCV delta T, remember. Okay. Then after delta U, what all the again one more formula, which one we had remembered? Mayer's relation. Mayer's relation is nothing but what? Cp minus Cv is equal to what? R. Where Cp and Cv are molar specific heat capacities of gas. R is universal gas constant. Clear? R is universal gas constant. Next, CV value is nothing but what? Fr by 2. CV is nothing but what? F into R divided by 2. Clear? Next, CP value is nothing but what? CP value, how you can remember? Can you just remember CP value? Just check it. If you are not remembering, means you can just simply you can calculate R plus CV, R plus FR by 2. R plus FR by 2 means take R common. R plus FR by 2. R inside the bracket, R plus F by 2. Clear? Directly. CP is equal to what we had got? R inside the bracket 1 plus F divided by 2. Next, gamma also we had calculated, correct now? Gamma is nothing but what? CP by CV. Clear? Try to remember the formula. If not, means within 5 seconds you should have to calculate that. CP value this one, CV value this one means what you are going to get? RR will cancel. In numerator F by 2, in denominator 1 plus F by 2. Take LCM, F divided by 2 plus F. F by 2 plus F means sorry, CP by CV. No, RR will get cancelled. This will be in the numerator 2 plus F divided by F. 2 plus F by F means 2 by F plus 1. Clear? 2 by F plus 1, where I can write that 2 by F plus 1 or 1 plus 2 by F, in that manner. Somehow you should have to remember. Next again, delta T value means change in temperature. Work done value integral PdV, which is always satisfiable condition. And some of the cases we had discussed, if sign convention, volume is increasing means, where shall I write? Volume increases means work done value positive. Clear? And cyclic process means clockwise means work done will be positive. Clear? Anti-clockwise means work done value will be negative. If volume is decreasing means work done value will be negative. Next, area under PV curve graphs gives work done. Already number of times we had discussed. Clear? And heat, for heat, what formula we had used? Q is equal to, for heat, NCV delta T. This is for constant volume. Clear? For constant pressure means what you have to write? NCP delta T. Clear? And work done equations in case of isothermal process, I hope you might have been remembered. In previous class we had discussed those things. So in case of isothermal process, okay, in case of isothermal process, work done value what we had calculated, nRT log of V2 by V1 to the base E. Clear? Next, in case of adiabatic process also we had calculated. What is the formula in case of adiabatic process? Can you tell me? Yes, come on. In case of adiabatic process, what is the formula for work done? NR by gamma minus 1, correct now? So in adiabatic process, work done value will be what? NR by gamma minus 1 divided, into gamma minus 1. 1 means T1 minus T2. Clear? I told you no, NR by gamma minus 1 inside the bracket T1 minus T2. So here second term what you are getting, like that here you will be getting first term, like that here you will be seeing that first term 1 T1, like that. And first law of thermodynamics, one more thing about first law of thermodynamics, yesterday I had forgotten. First law of thermodynamics, first law of thermodynamics signifies, or importance of first law of thermodynamics is nothing but importance of internal energy. Okay, signifies the value for internal energy. Clear? Because internal energy we are going to get now in that equation. What is that equation? What is that equation? First law of thermodynamics. First law of thermodynamics states that the amount of heat what we are giving to the system is, the amount of heat what we are giving to the system is utilized to increase its internal energy and external work done. Okay, it is nothing but, basically this is nothing but what? A law of conservation of energy. Law of conservation of energy. You should have to remember this point. Clear? And importance about first law of thermodynamics is nothing but what? It gives the concept of internal energy. Clear? It gives the concept of internal energy. Clear? So this is about all today's class. Correct? No? Lecture number 11. So in next class we will be discussing some competitive, very important things which is needed for competitive point of view. Based on slope, how they will be asking the problems, and some advanced level problems in JEE. Clear? How JEE is going to ask very high range questions in heat and thermodynamics chapter. So about this chapter, let me tell you, we are having number of formulas. Clear? But don't worry, if you can remember for heat and thermodynamics, means same formula you are going to apply in the case of next chapter, that is nothing but what? A kinetic theory of gases. So here only you become perfect, because kinetic theory of gases chapter will become very easy. That chapter is tiny chapter and easy chapter, and all the formulas what day to day we are discussing over here, all the formulas you practice, revise number of times, minimum 10 times you have to write each and every formula, then only you can remember. Write maximum number of times and utilize the time period. Okay, don't waste time. You are not going to get again this much huge amount of time. Clear? So keep studying, don't waste your time. All the best. Thank you.